Hi students, welcome back to online class. The last class we had discussed about what kinds of energy. Okay, we discussed mechanical energy. The what is the mechanical energy? The sum of the potential energy and the kinetic energy. That is what mechanical energy. So what is this potential energy? Potential energy is the stored energy of position possessed by an object. Yes. So today we are going to discussing the topic potential energy. What? Potential energy. See, an object can store energy as a result of its position. For example, see the position. The heavy ball of a demolition machine is storing. This is a demolition machine, and this storing energy when it is held at an elevated position. This stored energy of position is referred to as potential energy. Similarly, a drone. See the drone. John Bow is able to store energy as a result of its position. When assuming its usual position, that is when not drawn. Okay, there is no energy stored in the bow. Clear? Again, when Earth's position is altered from its usual equilibrium position, the bow is able to store energy by virtue of its position. This stored energy of position is referred to as potential energy. Potential energy, so potential energy is the stored energy of position possessed by an object. I hope all of you understood this. Yes. Now we are going to discussing gravitational potential energy. This gravitational potential energy is a type of potential energy. Okay. And one more is there, that is elastic potential energy. Is it clear? So gravitational potential energy. The two examples above illustrated the two forms of potential energy to be discussed in the course. Gravitational potential energy and elastic potential energy. Gravitational potential energy is the energy stored in an object as a result of its vertical position or height. See the figure? The object that's stored in a vertical height or position. Okay. So the energy is stored is a result of the gravitational attraction of the Earth for the object. The gravitational potential energy of the massive ball of a demolition machine is depends on two variables: the mass of the ball and the height to which it is raised. This is a direct relation between gravitational potential energy and the mass of the object. More massive objects have greater gravitational potential energy. There is also an direct relation between gravitational potential energy and the height of an object. The potential energy of the higher than the object is elevated. The greater the gravitational potential energy. Okay, so this relationship is expressed by the following equation. Potential energy or gravitational potential energy equals what? Mass into g. That means g means gravity into height. Okay, mass multiply gravity multiply height. So we can able to give what? P E, gravitational force, that means the gravity. Okay, gravitational potential energy equal to m into g into height. That means m multiply g multiply h. Okay, so this equation, m represents what? A mass of the object, and h represents the height of the object, and g4, yes, that is gravitational field of the strength, gravitational field strength, or what? Gravity. So you know that the gravity, what is the value of g? This common value, that is 9.8 Newton per kilogram on earth. That is common value. Okay. standard value of the gravity. Sometimes it's referred to as the acceleration of gravity. Okay. So, to determine the gravitational potential energy of an object, a zero height position must be um, attributably assigned. Typically, the ground is considered to be the position of the zero. See, the position of the considered to be zero height. Okay, but this is merely an arbitrarily assigned position that most people agree upon this. Okay, since mean our labs are done on tabletops. It is often customary to assign the tabletop to be the zero height position. Okay, zero height position. Again, this is merely arbitrary. If the tabletop is the zero position, then the potential energy of an object is based upon its height relative to the tabletop. For example, a pendulum bob swinging, okay, a pendulum bob swinging to and from above that tabletop has a potential energy that can be measured based on its height above the tabletop. Okay, so by measuring the mass of the bob and the height of the bob above the tabletop, the potential energy of the bob can be determined. Since the gravitational potential energy of an object is directly proportional to the height above the zero position, a doubling of the height will result in the doubling of the gravitational potential energy. A tripling of the height will result in the tripling of the gravitational potential energy. I hope all of you understood this. Yes. Now we are going to discussing elastic potential energy. What elastic potential energy? This is the second form of potential energy that we will discuss in elastic potential energy. Okay, so this elastic potential energy is the energy stored in an elastic materials as a result of their stretching or compressing. Elastic potential energy can be stored in rubber bands and bungee cords and trampoline springs and arrow drawn into bow arrow bonds. Okay, uh, next is yes, these are some examples. Okay, the amount of elastic potential energy stored in such a devices is related to the amount of stretch of the device. The more stretched, the more stored energy. Okay, more stretching means what? It's a more stored energy. You know that we feel it when we are stretching our bows. Is it clear? Yes. In your textbook, there is given one investigation with the springs, that is 4.2. Okay, so the springs are this special instance to a device that can store elastic potential energy due to either compression or stretching. A force is required to compressing a spring, or more compress there is. The more force is required to compress it further. For certain spring, the amount of force is directly proportional to the amount of stretched compressions. Okay, so the constant of proportionality is known as the spring constant. Is it clear? Yes. Such springs are said to follow Hooke's laws. Okay, if a spring is not stretched or compressed, okay, stretched or compressed, then there is no elastic potential energy stored in it. The spring is said to be at its equilibrium position. The equilibrium position is the position that the spring naturally assumes when there is no force applied to it. In terms of potential energy, the equilibrium position could be called the zero potential energy position. Okay, there is some special equations for that springs that related to the elastic potential energy to the amount of stretched and the spring constant. These we are learned in the higher classes. Okay, so this is elastic potential energy. Did you understand this elastic potential energy and our gravitational potential energy? Yes. So let us solve one numerical. Okay. See the question. A car is loaded with a brick and pulled at constant speed along an inclined plane to the height of a seat top. If the mass of the loaded car is 3 kg and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded car at the height of the seat top? See the figure, this is the figure. See the height. It's here, it's given that how much seat top, that is up to, this is a seat top, okay, up to 0.45 meter. And what is the mass of this loaded cart? It is 3 kg. Okay, so what we have to calculate, we need to calculate the loaded car at the height of the potential energy of the loaded car at the height of the seat top. Here, what is the potential energy? Okay, how to calculate this? What's the equation of this potential energy? Yes, that's right. Potential energy equal to m into g into h, which m for what? Mass, and g for gravity, and h for height. So here giving the values, put the values. What the m is equal to how much? 3 kg, and g, that we knows that it is a common value, that is standard value, 9.8 meters second square, that is kg. Okay, and height is also given here, 0.45 meter. Now put the values in the equation. Put potential energy equals PE equals what? 3 kg into 9.8 multiply 3 kg multiply 9.8 multiply 0.45 meters. Okay, what you will get the answer? Yes, 13.2 joule. Do you understand this? How to calculate the potential energy? Okay, so thank you.